Assalamu alaikum. My name is Vishal and I am BSBT student. Today the topic of my presentation is stearic acid. What is stearic acid? Stearic acid is a saturated monobasic acid with 18 carbon chain length. It is synthesized by both hydrolysis of animal's fat or from hydrogenation of cottonseed or vegetable oil. Commercially, stearic acid is a mixture of stearic acid with plasmatic and mystric acid. So there is a formula of stearic acid C18H3CO2. Melting point of stearic acid is 69.3 degrees Celsius. Manufacturing of stearic acid. The typical steps involved in manufacture of stearic acid: hydrolysis of fat oil to produce mixture of fatty acid and glycerine, separation of fatty acid and glycerine, purification and separation of fatty acid mixture into two or more fatty acid mixture. Application of stearic acid. Stearic acid is mainly in manufacture of soap, detergent, and several other cosmetics such as shaving creams and shampoos. Lubricant. Case. Release aid and additive of adhesive lubricant and greases. Mold release lubricant for centering, pressing ceramic powders and latex foam thickers. Food and beverage. Mold release for hard pressed candies, lubricant and greases. Mold release lubricant for straining, pressing ceramic powders and latex foam rubber products. Hydrostatic acid works as an activator, accelerator, and internal lubricant for both synthetic and natural rubber. So it's used in candles. We have already seen that stearic acid resemble wax, and that when added to product, it helps to harden and more solidify them. This make them idle. Use of stearic acid in pharmaceutical. In pharmaceutical, stearic acid is widely used as intermediate in pharmaceutical plastics. Stearic acid as a good gravity and light and heat stability. Is commonly employed for PVC pipe, platform profile film, manufacture heat stabilizer, manufacture PVC, plastic tube. Stearic acid is an efficient method for adding a heat stabilizer to processing of coke in PVC film and can cause sulfide finish film decolorization due to the protection storm. Stearic acid is applied in plastic as a lubricant and reduction of friction. It's used in playing cards. Once stearic acid reacts with zinc, zinc striate is formed. This is used as fanning powder, which helps lubricant playing cards and help in smooth shuffling, fanning, and so on of the cards. Use of stearic acid in batteries. In making of lead acid batteries, stearic acid is used as an active plate additive, and it helps to improve the plate hydrophobically, especially when the battery has to be dry charge. The stearic acid helps to reduce the oxidation extension of active material or the lead, which form afresh when plates are left to dry in the open after the tank formation process is completed. This helps to reduce the time required for changing the dry battery for the first time when compared to the battery that does not feature added stearic acid in its place. Use of stearic acid in fireworks. Stearic acid is often used in fireworks for coating aluminium, iron, and other metal powders. This helps to prevent or delay the onset of oxidation and extend the shelf life of composition. You can store them for a longer period of time. Paints and coatings. Stearic acid is used directly in some paints in the paint sector, for example in cement paints, and that is indirectly in different formation of coatings such as zinc straight, additive, etc. So it's used in rubber. Stearic acid of rubber grade that we often come from well-known organization. This rubber grade stearic acid is used in the processing of rubber compound as a dispersing agent, plasticizer, and lubricant. As it is generally chemical, the use of stearic acid can be found in industrial application as well. It is often used to make the casting of molds. The castings are usually made of piece of plaster or broken waste mold. Clay is used to make molds using stearic acid. Here stearic acid is powdered and mixed in water. This mixture is applied to the surface that will separate once the casting is over. This solution has chemical reaction with the calcium present in the plaster and form calcium striate. This chemical helps to release the cast easily and quickly. How does stearic acid works? Basically, stearic acid is used to manufacture products. So, stearic acid is used to manufacture products like emulsifier, lubricants, ointments, lotions, emulsion, and so on. Stearic acid effectively stabilizes thickness and often helping to create a cooling sensation when the moisturizer or ointment is applied on the skin. Stearic acid also lends a smooth pearl-like production of stearic acid. In terms of its biosynthesis, stearic acid is produced from CoA, with CoA are two carbon building blocks after decarbonization. Stearic acid is obtained from the fats and oils by the saponification of triglycerides using hot water about 100 degrees Celsius. The resulting mixture is then distilled. Commercial stearic acid is often a mixture of stearic and plasmatic acid. Although purified stearic acid is available commercially, oleic acid, as found in palm and soy, can be hydrogenated to give stearic acid. Metabolism of stearic acid. An isotope labeling study in humans concerned that the fraction of dietary stearic acid that oxidatively deteriorates to oleic acid is 2.4 times higher than the fraction of palmitic acid, analogously converted to palmitoleic acid. Also, stearic acid is less likely to be incorporated into cholesterol ester in epidemiological and clinical studies. Stearic acid was found to be associated with lowered LDL cholesterol in comparison with other saturated fatty acids. So here is the structure of stearic acid. You can see. Basically, this is stearic acid. ये white color का जो भी है. Chemical properties of stearic acid. Stearic acid CH3CH2 16COOH is a white or colorless wax-like solid with melting point of 70 degrees Celsius and a boiling point of 232 degrees Celsius at 2 kPa. It is soluble in alcohol, ether, and chloroform and is insoluble in water. pH of stearic acid. Well, as it turned out, stearic acid has a pH of 6 while water has pH of 7. This means that this is only slightly more acidic than water. Is stearic acid soluble in water? Stearic acid is a saturated fatty acid that can deposit on the surface in special conditions. This acid is insoluble in water and soluble in ethanol. Composition of stearic acid. The chemical formula of stearic acid is C, as ऊपर भी पढ़ा था ये वाला formula, C18H36O2. In its solid form, it appears as white solid and has mild, pungent, oily odor. It floats on water. Its function as a plant metabolites and algal metabolites are Fania magna metabolites and human metabolites. Benefits of stearic acid. Stearic acid is a form of emollient that is quite effective in moisturizing and hydrating the skin. It protects the skin by forming a moisturizer barrier from moisturizer loss and keep it hydrated for longer time. So basically, this has a very advanced effect on our body, especially on our skin. It is especially beneficial for people with dry skin. So people who has dry skin can use stearic acid. How stearic acid is made? So basically, this is stearic acid. The production of ingredient involves the hydrolysis of common animal and vegetable fats and oils, followed by fractionation, distillation, or crystallization of the resultant fatty acid. Pressing methods separate the liquid unsaturated fatty acids from the solid saturated fatty acids. The ingredients used in cosmetics usually undergo 2 or 3 pressing processes, resulting in different concentrations. Cosmetic grade stearic acid are often a mixture of fatty acid depending on their manufacturing and source. They are often combined with plasmatic acid. Environmental safety of stearic acid. How safe is ingredient for our planet? For its biographically to its impact on aquatic life. Learn more about its effect on environment. Biodegradability. Stearic acid is considered readily biodegradability, meaning that it can break down relatively quickly in the environment. Microorganisms such as bacteria play a significant role in breaking down the ingredient into simpler compounds, eventually converting it into carbon dioxide, water, and other natural elements. This process helps reduce the potential of fatty acid to accumulate in the environment, thus limiting its ecological impact. Aquatic life safety. Although the ingredient is biodegradable, it can be harmful for aquatic life. It releases into water bodies in large quantities. High concentration of stearic acid may cause oxygen depletion in water. So it is harmful for aquatic life, leading the adverse effect on fish and other aquatic organisms. However, given its biodegradable nature and limited solubility in water, the risk of ingredient causing long-term harm to aquatic life is relatively low when released in control amount. So here my presentation is ended. Thanks for listening. Allah Hafiz.